Okay, for this problem, what we are asked to do is to find the equation of the tangent line to the graph of f of x equal to minus 4 tangent x minus 4 times tangent of x minus 3 plus 2 pi, which I'm gonna not use a symbol for this line here. We're gonna use just pi. All right, so I think that's the right problem for which we want to find the tangent line. And I'm just making sure that I copied that correctly. So then now the first, and it was just a little bit more because they actually want you to do it at a point. So it's at x equals pi minus pi over 4. Okay, all right, so we have our problem. So whenever they ask for the tangent line, what we need to figure out is the slope first, because a very useful equation is the point slope form of the line. So there's a couple of things here that are going on. Oops, should be a 1. It's a 1 because they want a line, right? So this is the point slope form of the line. But then we want a tangent line. So they're really asking us to find f prime. So I'll put that note up here, f prime. To find the slope of the tangent line, and which is going to be the m in my formula. And then the other thing that is worth noting maybe at this point is that if we're going to use point slope form, we have our x1 over here. Okay, we'll revisit all those ideas if you missed something. But let's start first with finding f prime. So, and then we'll come back to, once we find f prime, then we should be able to come back to that piece there. All right, so to find f prime, I need to find the derivative of this piece first. And so I guess there's one other thing that we should have written down, is that the derivative of tangent of x, and this is a rule or theorem, is secant squared x. Okay, so those are the facts that we're going to use, and I think now we've got all the major parts in place that we need. So the derivative of f is minus 4, because that's a constant, and I need the derivative of tangent x, which I already wrote down, is secant squared x. And then, in fact, all these colors aren't confusing, but this is a constant number. So the derivative of a constant is 0. So I'm done with the derivative. Now that's the slope of the tangent line, which I could use that formula inside this other formula that occurs to me, but because they're giving us a real specific value over here at x equal pi over 4, we might as well evaluate it and just deal with a number. So f prime of minus pi, and I'm going to use a symbol over 4, is -4 secant squared minus pi over 4. All right, so that might be a little bit tricky. We might have to think about that a little bit. And the way this makes the most sense for me, and you may have a different way that works for you. You may be able to work with a secant directly. You may want to plug this into your calculator. But what I will draw on is that secant is 1 over cosine. So that means my cosine ends up in the denominator. Okay. And then, of course, I could use a calculator to try to evaluate it. But what I'd rather do, if I can remember how to use my unit circle, and so that's the center of my unit circle. So I have to remember where minus pi over 4 is, and so that I can figure out what cosine is. All right, so let's keep that. Let's just use a different color. Let's go the maroon's dark enough. So pi over 4 minus pi over 4 is going to be over here, right? So this angle here is minus pi over 4. And so my point there, and granted my drawing is fairly imperfect, but if my picture at least helps you go back into your memory, then that's enough. But the point there, for the unit circle on a coordinate axis, is √2 over 2, that's the x coordinate, and minus √2 over 2. And so because we're looking at cosine, then it's the x coordinate that I need. So it's root 2 over 2 squared, which becomes -4 times 4, because this moves to the top. You may have to think a little bit about why that happens. And so this becomes -8. All right, so that's a nice number that I can work with. And I am going to do some work over here using that formula there. So it's going to be y minus, I don't have a y1, so I'm going to need to acquire that here in a minute, and that might require a little bit of work. Is equal to m, so that's done. That's the -8 times x minus x1. That's the minus pi over 4 from over here. So I'm going to just put this as pi over 4 because two minuses make a plus. Okay, so now I have to plug this into f. All right, so let's see if I can do that up here in this corner. It might have been worth doing that at the outset, but it's okay. So I'm going to plug in a minus pi over 4 into this function. So it's -4 times the tangent of minus pi over 4 and -3 plus 2 pi. Okay, so that looks sort of complicated. Put the equal sign over here. But actually, just looking at the tangent of minus pi over 4, well, the nice thing is that I already have my unit circle. So minus pi, the tangent of minus pi over 4 is sine over cosine. Well, sine and cosine are the same, except the numerator is going to have a negative sign. So this is going to be -4 times -1. So that's going to be 4. Okay. And that said, I'm just double checking things. Okay, so -3 plus 2 pi. So 4 minus 3 is 1 plus 2 pi. Now remember, 2 pi is I'm going to start putting some numbers in here to make it a little easier for us. Or perhaps maybe it's better not to, actually. So this is 1 plus 2 pi. Maybe it's better not to. 1 plus 4 minus 3 is 1 plus 2 pi. So this is going to be 1 plus 2 pi. Maybe a little hard to read, but not so much in the next line. So -1 minus 2 pi. And then I'm going to distribute that 8. So it's going to be minus 8 minus 2 pi. Oh, that works out quite nicely, I would say. Except I don't want to lose my x there. So this is going to work out really nicely because those two are identical. So they will definitely cancel. And one of the last things I need to do is add a 1. So I'm left with y is equal to negative 8x plus 1. And that's the equation of our line. Now, if I recall correctly, you may be asked to graph that. And so just very, very quickly here, I'll just remind you here that the y-intercept is 1 and the slope is negative. So it's going to go something like this. You know, those are going to be arrows for the line. This is going to be a 1 because of the 1 over here. We'll do it this way. And then it's an arrow. And the slope of that line is going to be negative 8. Okay, so that should give you enough information to solve this problem. If we're looking for the equation of the tangent line, it's this one over here. And then if we're asked to graph it, it should look roughly like that. All right, that's how you do this kind of problem.